Hi, everybody. This is Nalini Elkins with Industry Network Technology Council. Maybe somebody can send me a quick note and let me know if you're hearing me okay. That would be wonderful. As always, we are recording this webinar so that others can have it after, and you can have it after as well, just so that everybody knows that we are being recorded. So. Okay. Yes. Can somebody send me a quick note to let me know that you're hearing me okay? That would be great. I don't want to go ahead and keep going without people saying that. Perfect. Okay. All right. So everybody can hear me. Okay. So let's keep going. Okay. So these webinars are a collaboration between a nonprofit group in India, the India Internet Engineering Society, and a nonprofit group in the United States, Industry Network Technology Council. The INTC in the United States aims to have global reach. We are, of course, not U.S. specific because the internet itself is not U.S. specific. In the past, we have had grants from the Asia Pacific APNIC, the Internet Registry for the Asia Pacific region, and ARIN, the American Registry for Internet Numbers, the Registry for the North America, and we will get grants again, I am sure, but this is kind of an in-between time. So, but we want to continue doing what we're doing because this is our focus. It is a multi-year project, and it is aimed specifically at large enterprises to do IPv6 deployment. And this particular one is an interesting webinar because without getting your mainframe into IPv6, without having your mainframe do IPv6, you will not complete your implementation. As Rob will tell you, many of the databases in the back end are on the mainframe. If you guys are on this webcast, I don't need to tell you. You already know everything that I would say about that. We're, I think, doing pretty well this year. This year we will be focusing on different topics. We've already started with the mainframe topic. In December, we'll have V6 and 5G. I'll be sending out notices for that webinar. That should be exciting. We will be having a number of sessions on V6 and IoT. We're still finalizing those. That should be a lot of fun. V6 security, IPv6 and DDI. Lots more things coming up. Keep posted. I'm sure you guys are all on our email list, and then we will send you notices. If you have other ideas, things that you would like to see, please go ahead and let me know. I'll just leave this in here for those of you to whom I am new. I've been working in this industry for a long time and still get up in the morning ready to go. As I say, I've never fallen out of love with all this stuff. Craziness, pure craziness, but there we are. So now let me tell you about Rob. So Rob is going to be doing this presentation. And I met Rob when we were writing RFC 8250. And it has just been a wonderful experience working with him. He is a geek's geek. And what you will hear on this presentation is the down and dirty stuff of exactly how you go forth and do an implementation. And you know, he was going to put all this stuff into one, and we got to an hour and a half. I'm like, okay, we got to have 2 presentations, and there's more coming. So just let me know, and then we can certainly twist Rob's arm to talk maybe about ZVM, socket programming on ZOS, IPv6 related, and so on. Just let us know what you would like, and let's go. Let's go. So let me turn this now over to Rob and let him present. Thank you so much, Rob.
Thanks, Nalini. That was really nice. I like being the geek's geek here, I guess. That's okay. So what we're going to talk about is getting to IPv6 on your mainframe. There are, and I've done this. I did this a long time ago. When I say a long time ago, that means more than 10 years. And there were various reasons why I kicked it off, why I got started going in this direction. At the turn of the century, I was writing an application for the company I'm with now, Chemical Abstract Service. And I went to the guy in charge of the network and I says, so should I be supporting IPv6 as well as IPv4 or what? And his comment to me was, well, we're never going to be going to IPv6. So yeah, you don't have to worry about that. I'm like, okay, so here we are. Again, I'm with the Chemical Abstract Service, which is a division of the American Chemical Society. Just so you know who we are and what we do, we actually, I hate to say it myself, a lot of people like to use the phrase that we are like a Google for chemists. We read regularly thousands and thousands of scientific journals. We abstract the information out of those. We keep track of all chemical substances in the open chemistry literature, okay? So that's why we say we've got over 250 million substances here. That is true. We also keep track of all chemical reactions. We've got well over 1 billion chemical reactions in our database so that you can search and find out what, if you're going to put a couple of things together, here's what you should expect to have happen. We store chemical structures so that you can actually search for something in the database based on what the chemical structure is that you've observed. We track DNA and RNA sequences. One of the more important things that we've done lately is to support those who are working on cures for diseases, particularly COVID-19. Let's see here. We also support IP claims. We are associated with 64 patent offices worldwide, so whenever they talk about IP at work, I know they're not talking about what I know about, they're talking about intellectual property. And so anyway, we keep track of that information as well. And of course, the all important cosmetic formulations. So those are just some of the things that we track in our databases. We extract information out of the open chemistry literature all the time and provide that information to those who can use it, and that means an awful lot of these people. You're talking about 48 of the top 50 pharmaceutical biotech companies, chemistry companies, 100 of the top 100 academic institutions, and again, the top 10 global patent offices. So we support all of those folk. This is our logo, and honestly, I'm not marketing. Several of these slides are given to me for marketing in order to be able to pass that information on to you about who we are. As you'll note from all of my slides today, I'm on the hindsight part. You'll see that that part of the logo is out in all of my slides later on. So again, as Nalini told you, I came up with a presentation to do both ZVS and CVM, how I implemented those, how I implemented IPv6 in those environments. We cut it in half. We got rid of the ZVM part, and we may save that for later. And then we were going through it and discovered that it was still going to be way too long, and so we kind of cut it in half again. So we're going to be getting through just the first several steps, probably maybe half of the work here in order to get you going with IPv6 on your mainframe. All right. Now, before I go any further, once again, I can really show you who and where we are. I'm going to come out here to, I'm going to go to Wikipedia, and I'm going to look up the random elements in the periodic table. You can see here's where thorium is in the periodic table. The important thing about this guy is this right down here. You see this CAS number. This is a CAS registry number. This is us. We put these numbers together. You can see we include in our registry database all substances described from 1957 through the present, plus again some substances from as far back as the early 1800s. So we have information about lots and lots of chemical substances, and we make that available for students and educators, and in addition, people like your local police department and so on and so forth, so that they can determine what kind of substances they're looking at. I know one night I was watching the original CSI show with William Peterson on TV, and I saw that on one of their PCs behind them as they were talking was our homepage. So I was impressed. So in any case, just to get started on phase one here, just a couple of disclaimers. What I'm going to tell you about is, here is the journey that I made. Here are the steps that I took, generalized to make them look a lot better. Your network's going to be different from mine. That's fine. These steps will work on your network as well, but one way or another, we will get you, either get you there or get you well on your way on your migration journey to IPv6. Alrighty. As always, the usual disclaimer: the IP addresses here that aren't publicly available have been changed, along with the names of the other configurable items and hardware, in order to protect the guy that wrote this, which of course would be me. Let's see now. Get rid of that. Oh, why are we talking about IPv6 on the mainframe? I think that if you're here, we probably already know some of those answers. Mainframes are used by everybody. Okay, 71% of Fortune 500, 92% of the world's top banks, top 10 insurers, top 25 retailers, airlines, hotels. Everybody is using mainframe, either for processing or for data management, database management, either way. So yeah, everybody's using them, and they actually handle most credit card transactions in the world today. Okay, this is why those banks are using them. Credit card transactions, ATM transactions, billions of transactions every day, and a single Z15 can handle over 1 million transactions every second. Okay, so when people tell me how great their PC is, I say, hey, yeah, mine's better. Okay, I just want you to know. Some years ago, well, actually, the mainframe's been doing virtualization since the 1960s. So the mainframe is really good at it. The mainframe was the original cloud. Okay, long before there were PCs, the mainframes were performing what we see as cloud activities today. All right. Back around the turn of the century, this century, the guy was running tests to see just how many Linux servers we could run concurrently under VM, and that's not VMware, that's VM that we now know as ZVM. He had one mainframe. He configured it up with VM and set it to start running Linux servers. And at one point, they just let it take off and load up as many Linux servers as it could. And it was able to run that many, 97,943 Linux servers before it stopped. And it didn't, the machine didn't stop. It kept running. It just didn't start up anymore at that point. So you can imagine how much the technology has improved over the last 20 odd years, okay? That's why we're talking about all of these things. This is why we're talking about IPv6 on the mainframe. And if you haven't, then it's time, okay? This is what you don't want to see. You do not want to have your mainframe being left behind because people can't talk to it. People with IPv6 sitting there on their phone or on their iPad or on a PC, they need to be able to talk to and obtain the data off your mainframe. And you want to be part of the discussion. You want to be, you don't want to just be, again, the legacy guy. Now, as I was doing my implementation, I used this ZOS Communication Server IPv6 Network and Application Design Guide, or the NADG, I call it the NADG, and it's been my best friend for several years, okay? Which probably says more about me than about the book, but honestly, this guide gave me all the information that I needed in order to do all of this, all the migration that we're going to talk about here. So now, just to talk about, to give you a quick list of the steps that we need to take. All right. The most important step up front is for you to do some planning. And I will go through a couple of slides to talk about the things you need to plan. We will enable IPv6 sockets. I've got just a couple of slides here that show you everything you need to do in order to enable IPv6 sockets. And then we'll have to talk about some addressing to find some the IPv6 addresses and your addressing architecture to your mainframe so that you can communicate with applications and people elsewhere. And then once we have all of that done, then we actually will configure the IPv6 communication components, the interfaces to your OSs and your hypersockets and such. That part we'll actually get into the next session, but the first three of those we will cover today. So what should we be able to do by the time that we're done today? Well, this is great. We're going to be able to create IPv6 sockets. We'll be able to communicate over those sockets to other applications on your same ZOS system. And we'll configure up the resolver, the task that actually allows you to do IPv6 and IPv4 name and address lookups. All right, so we will, those are all the things that we'll be able to do based on everything we talk about today. So when we start talking about planning, there are two kinds of items. We can have a dual mode stack, and basically the dual mode stack supporting both IPv4 and IPv6. Basically what they're saying is, I'm sorry, right now you cannot have an IPv6 only stack in ZOS, which is okay. Good heavens, we are multilingual here. So then we have to decide, okay, if I'm going to create myself a dual mode stack in order to work with IPv6, is it okay at my site to do that on the production or the primary stack? Now, as it happens on my systems, we're a fairly small ZOS shop. I've got 4 ZOS LPARs along with a couple of ZVM systems. Each of my ZOS LPARs today has 2 IP stacks on it. My sandbox LPAR, where we actually get to do all of our maintenance and the like, has the primary IP stack and the test IP stack, and that was the best place for me. I was able to use a test IP stack, which actually was connected to, well, there was a real network there, but there was nothing else on the network. That was a good thing because that meant that I didn't send out any of my IPv6 packets out to the rest of the world until I was ready to, and vice versa. I did not have to put up with any incoming IPv6 packets. I could just make the connections work and go forward with that. So in my case, that meant I updated my test IP stack, and then I moved forward to my production stack, one LPAR at a time. That meant, because I have a fairly stringent change control system in place where we work, that meant that this was a long time. It actually took quite a while from the time I actually started working on this to where I finally got all the configuration done. Okay. If it's possible and you're using a secondary stack, you should use a test stack, again, that is connectivity restricted. There are some rules on that, and we'll get into that when we talk about the routing the next time, but that, again, allows you to just be in control of all the IPv6 traffic that's going on. And then you need to talk about what kind of applications you're going to enable. In my case, I have a couple of applications that were migrated to use IPv6. The actual upgrades to those applications did not take very long. As it happens, those applications were being overhauled for something else, and so it ended up taking a long time. But the actual IPv6 modifications did not take very long at all, and we'll talk about that later. One of the other things you should do is to watch the other webinars in this series to learn about IPv6 addressing. You need to be able to define addresses for your ZOS systems, and you need to be able to talk about what you want your applications to use, how you want the addresses organized for your applications, and so on and so forth. That's all the important stuff as far as planning your IPv6 implementation. All right. Any questions about that off the top of your head? And I'll pause there for just a second.
Thank you so much. Yes, if anybody has questions, please go ahead and put them in the questions window. I think it'll be a little bit before, since we're still in a little overview part. And so, yeah, just thank you. And I don't have any questions so far, so let's keep going.
Let's keep going. Okay. So what do we have to do to enable IPv6 sockets? Okay, well, in ZOS, sockets are all handled by OMBS. He handles anything and everything, and this configuration is in this BPX PRM and some member of Sys1 ParmLab. Okay, that's fairly ordinary as far as ZOS components go. So that's the guy that we need to modify in order to enable IPv6 sockets. Fortunately, it already has some of those configuration items that you need. So let's give it a look. This looks remarkably like what is in my own BPX part members. This guy right here, file sys type. Okay, you need to make sure if you are going to have more than one IP stack, then you need to specify CINet. Otherwise, you can just say file sys type with a type of INET. The difference between CINet and INET is not between IPv4 and IPv6, but how many IP stacks are you supporting, okay? Now this right here is in the, again, the globally recognized family name for IPv4 sockets, AFINet, plus the slightly less globally recognized domain number 2. This is what you need. This network definition defines 2 OMBS IPv4 sockets. So this allows you to do IPv4 sockets. And we'll have another thing just like that, using these, again, way less recognizable addressing family name for IPv6, AFINet 6, and the definitely unrecognizable domain number of 19, okay? you add this piece right here, and this enables IPv6 sockets for you. In other words, it tells OMBS that you can create an IPv6 socket. Now, some of these other numbers, the max sockets and that or any port enter, these things are all specific to each network. In other words, if I say 64,000 here, I don't have to say 64,000 here. I don't have to cut this in half to 32 and 32. They are all independent, okay? Now, beyond that, you're going to have this subfile systype. You're going to have one of each of these for each of your IP stacks, okay? So this would be the IP stack name. This is somebody else's IP stacks because those names are not familiar to me. But you're going to have a subfile systype because each IP stack looks kind of like a physical file system to OMBS, okay? That's what sockets look like. So if you add a test stack, then you would be adding a subfile systype entry into your BPX params to support that, okay? The other important thing, as I was saying, this type CINet, you'll see that is common among all of these entries, right? And that is, first off, if we only had one subfile systype entry and we only had one IP stack we were supporting, we could put just INET. Otherwise, we have to specify the common INET as the subfile systype type and as the file systype type, okay? I've probably pounded on that just about enough. Go ahead.
So Rob, I'm going to interrupt you just a second here. So the CNET, it does not mean, so if you had one TCP basically, then you could INET. It just because you have IPv4 and IPv6, you could have all of that within one TCP/IP stack. Just those two protocols does not mean you have a second TCP/IP. Is that a correct statement?
That is correct. That's absolutely right. This basically is about socket management that OMBS is going to do, not about the interaction with your IP stacks. Okay, so that's what I was trying to say. Yeah, we don't just put CINet because we're going to do both IPv4 and IPv6. I put CINet because I've got multiple stacks down here. Yes, that's correct.
Yes, yes, because I know a lot of people think that you know, they say, I have two protocol stacks. I have the V4 stack and the V6 stack. That is not what Rob means. He means an entire, the TCP/IP address space that runs on the mainframe. Is that a true statement there, Rob?
Absolutely, absolutely. We have different network entries, one for IPv4 and one for IPv6. And there are others out there. There's like an AF Unix or an AF IUCV. Domain name network entries out there, but these two here are the ones that control IPv4 and IPv6. And again, you could only be running one IP stack, in which case you could just put type INET for all of those, and that would be fine. Yes.
Great, thank you.
Yep. Now, the other thing that you need to do is to take a look at your TCP/IP profile, all right? You've already got an IPconfig statement in there right now. It probably has some of these. I'm sure there's like a dozen or 15 or more different options you can specify to IPconfig. Ignore redirect, it's just the best practice. Path MTU discovery is IPv4 specific, but the IPconfig statement itself configures your TCP/IP stack to communicate with IPv4. In order to add IPv6 to your stack, you just put in an IPconfig 6 statement. It's just like this guy, only, you know, up here the 4 is silent, okay? So down here we've got just the IPv6 specific options like ignore redirect, that actually works for both. That's great. Source VIPA, I use that stuff everywhere. But ignore redirect is one of those best practices you want to make sure that you put in there. Other than that, and again, there's probably a dozen different options that you can specify based on your network and based on your implementation, okay? But that said, once you have your BPX parms upgraded, and you do a set to MBS equals, or you reboot your system, or whichever you like, and you add your IPconfig 6 guy into your TCP/IP profile, these are the things that configure your IP stack in order to be able to use IPv6 sockets. Those two things together, that's it, okay? You can, at this point, once these things are active, you can you can start using sockets with, Rex or any kind of program that you like. You can start using your IPv6 sockets. You can start doing some communication back and forth with anything else that already knows about. Well, you can actually use IPv4 mapped IPv6 addresses, and you can talk to another application using those, okay? By and large, you still can't send IPv6 packets themselves off of your IP stack to somewhere else until we actually configure the interfaces. And again, we'll cover that in a couple of weeks. But basically, right now, you can start doing your application work and creating IPv6 sockets. This is a good thing. So, next, yes,
Rob,
go ahead.
Go back to that previous slide for a second. So one question we have is, so there's other things in the TCP profile, the TCP buffer sizes, UDP buffer sizes, and so on. Now, those will all remain the same for both V4 and V6. Is that a correct statement?
Absolutely. This is the only change that you need to make in order to enable your stack to use IPv6 sockets in order to do IPv6 traffic. Everything else stays just the same. You've got a global config, you've got SMP stuff, whatever. But at least this much, at least putting in the IPconfig 6 statement enables your stack to do IPv6. It enables the stack for IPv6. I remember when I got this stuff, in fact, just enabling the IPv6 sockets with OMBS, you do a netstat up, and at the very end of the message, it says, with IPv6 enabled. Boy, I was excited when I saw that happen. But then, I'm the geek of geeks here, so, I'm just letting you know. Yes, this is the only change that you need to make in order to enable your stack for IPv6. Okay.
So one of the reasons I was asking too is that I know, and this may be different. I know at least on certain versions of other operating systems, they will have these specific TCP buffer sizes and for specific TCP buffer sizes. That is not true on ZOS. I guess that's what the question too.
I've not gone into that level of tuning on our systems in order to adjust that. But yeah, I think that you're correct. The buffering and the like is handled regardless of the protocol on the socket, and that's because we're supporting 4 or 5 different kinds of networking protocols with TCP/IP on ZOS. And so, yeah, a lot of things like your TCP buffer sizes and the like, those things are all irrespective of the IP protocol that you're running.
Great, thank you.
Okay. So again, we've, as I mentioned earlier, take a look at all of the webinars that that Nalini and Mike have done, talking about the different kinds of addresses and how you want to define your addresses, what kind of an architecture you want to create for your IPv6 network at your site. Okay. If I were to talk about this session would run for many hours, and so we're not going to do that. What I'm really going to do here is I'm going to say, by the way, IPv6 Network and Application Design Guide says to stop using, do not use IP addresses for identifying remote hosts. Okay, this is an important thing to note up front, and this is why. Okay, this right here, that is an IPv6 address. If for no other reason, that's why I'd rather put in a name instead of try to specify it by all of those numbers. And that's why what I really want to talk about here is name and address resolution. Okay, going into the resolver and setting up in the resolver how you can find out what your names and addresses are for your IPv6 connections and hosts. All right. Now, if you're using IPv4, then you know that host local, host site info, host adder info, those are all IPv4 specific. They do supply lots of information for your IPv4 connections. And when you have IPv6 enabled, those will all still work, okay? But the problem is, again, they're IPv4 specific. They don't work for IPv6 names and addresses, all right? So there's this other file. In fact, it's not just a file, it really is an entire search stream, if you will. Etsy IP nodes is where you can put your IPv6 names and addresses. And in fact, it's the only place that you can put IPv6 names and addresses. But the good thing is that you can put your IPv4 names and addresses in the same file. So in other words, you can get away with, or you can survive and do well with just one Etsy IP nodes file. I do. I upgrade it when I need to, but basically we have just one for all of our ZOS systems. And in fact, the format of Etsy IP nodes is very different from host local. In fact, it's much more like what you would find on any other platform, okay? So in fact, I use my Etsy IP nodes guy on both ZOS and ZVM for all of the IPv4 and IPv6 names and addresses that the mainframe needs to know about. So this means, yeah, you don't need host local. You don't need all of those derivatives. You can mix everything together inside your Etsy IP nodes guy. And this sounds more like anyway, this sounds more like a fervor note here that says, this allows the administration of localhost files to more closely resemble that on other platforms and eliminates the needs for post-processing the files with something like makesite. All right. So that's sort of another disclaimer. Now, for setting up the resolver, okay, there's a setup DD statement that points to a file for the resolver. And this guy includes, among another number of other specifications, global IP nodes, which points to a data set or some ZFS file reference. There's default IP nodes, which also points to a data set or a ZFS file reference. And the other thing we care about is common search or no common search. And I'll get to that guy in 2 slides, I promise. But what we need to do is to create a search order for Etsy IP nodes. Well, actually, he already has one. The first thing in the search order is whatever you specified as global IP nodes. So if you put that in, that's the first place he's going to look. He finds the answer there. He's not going to look any further. Now, if you happen to be running an OMBS, This environment variable, resolver IP nodes, again, that can point to either an MBS data set or a ZFS file. And that contains Etsy IP nodes type data to allow you to resolve names and addresses. These things are useful. The extra ones are useful if you're going to have like an application that while you are migrating it, okay, you might want to have a separate file specific to the application that contains just the IP nodes data that you need for that application. All right, see, for me, I went through during my planning stage and I took all of the IP addresses in my host local and I put them in an Etsy IP nodes data set. And that's all I used. As I was doing my migration, I kept, basically the addresses and the like had already been added into this table, and so they were automatically available as the application was capable of using them. And you can see that this, again, it can be either a user ID or a job name. That's great. That will be the next spot that the resolver looks for IPv6 or IPv4 demographics. Now this HLQ, this is the next stop. You can say this name would be like the TCP/IP job name or the highest level qualifier for your TCP/IP data sets. It's already configured in your TCP/IP data file. I believe it's also specified in the resolver configuration. Okay, so this guy is the next place. And just about the last place is this default IP node specification. I actually use this. This is what I specify for my resolver. This is down at the bottom. It allows me to go in up front and sort of override whatever is in this data set. If I need to make any changes in advance, of trying to run an application, I could, set something else up in order to be able to do that. To me, that's a little bit of hacking, but, and here's one last place, /Etsy/IP nodes over at OMBS. You can use this. You will look here, absolutely dead last, okay? I just try to make sure that everything is at least in default IP nodes or higher in the list, higher in the search order, okay? So this is the search order. And again, I pulled this out of the NADS to actually say, hey, you could put Etsy IP nodes information in any of those places. I have it in one, and that's what I specify as my default. I could specify that as global, but then that would prevent me from doing other, overrides here. Up to you. That's another one of the things that is dependent on how you want to set up your addressing architecture. Now, the next thing is this common search or no common search. Now, obviously, we have to have a way of saying which places we want to look for what. This tells the resolver, if you say common search, that I want to use the same search order and the same search files for IPv4 and IPv6 name and address resolution. Okay, to me, this is a good thing. It means at my site, I only have to maintain a single source for domain name and IP address information on the mainframe, okay? Now, people might ask, well, why don't I use the, the company's DNS servers? Well, that's great, except that they don't support IPv6 and they don't know about hypersockets, and this is easier. This allows me to keep control on the mainframe of the names and addresses that I need to know about. Common search says I'm just going to use that Etsy IP nodes guy for both the IPv4 and IPv6 demographics. Now, if I specify no common search, that means that we're going to use host local and his brothers for any IPv4 name and address resolution, and then use the Etsy IP nodes search order for both IPv4 and IPv6 name and address resolution, okay? So those are, basically, this is how you set up the ability for you to just reference something by name instead of a long string of numbers, okay? the resolver is where I keep everything as far as all of the mainframe applications, all the mainframe interfaces. My Etsy IP nodes file is shared between my ZVM and ZOS systems. I use the same names file in both cases. And the last time I went and looked, I've got something over 215 or so names and addresses. Actually, that many IP addresses inside my Etsy IP nodes data set. So I didn't want to have to maintain both that and host local. So once I went to Etsy IP nodes, I just got rid of all of the host local, host router info, host site info. Any questions about that?
So I guess if you're just starting out, you know, if I have like maybe 1 or 2 IP addresses, I could, you know, or maybe 5, you know, maybe I can skip past this for a bit and then come back, because I think, of course, what you say is correct. If you get more than 5, you know, your eyes are going to start to cross. But like, you know, maybe you see what I'm saying, Rob? It's like,
Absolutely,
it's like,
absolutely. You can start out with, and I know the numbers because I defined what they are for all of my HyperSockets connections and all of my links between my systems and so on and so forth. And so I know all those IP addresses, but I'd just as rather be able to use a name in order to make that connection instead of having to use a 20-character IP address.
sure. Now I understand.
Yes, absolutely. And frankly, that's I don't want to say that that's all we have for today, but basically that's it as far as those first 3 big steps on our way. Just to let you know, what does, how did I start doing this? What does my timeline look like? Again, my restrictions as far as how long it took me to do stuff, I had again, a fairly stringent change control board. The mainframe networking team on this project is me, and the software development team on this project is, well, that's me too. It's just kind of a learn as you go. And there were, again, 2 primary software applications that use this. The upgrades to those were substantial, entirely unrelated to the IPv6 implementation. The actual implementation of those guys just didn't take very long. So a lot of the work overlapped, so it took a long time. But I made it happen. One of the things that kicked it off to begin with was the Office of Managing Very Big Budgets says that we wanted federal agencies to begin addressing key IPv6 planning considerations. I'm not really sure what that means. I mean, I'd like to get a government English dictionary, but I'm sure that they would say, we could give you one, but then, 3 months after that, the general guidance, governmental office issued a guidance to say that they wanted this done by June of 2008, okay? I don't think it happened. I'm pretty sure it didn't happen. For all government agencies to convert their network backbones to IPv6, and I'm sure by that they meant to do some sort of a double stack mechanism so that people could use both IPv4 and IPv6. But when I saw that, I said, wow, this is great. We are not the governmental agency ourselves, but we work with the United States federal government as a client. And so I started back in the spring of 2008 just to experiment with turning on IPv6. I went to a disaster recovery test, which actually is closer to my house than where I work. I showed up out of the blue and said, hey guys, let's try IPv6 sockets here in our BPX params. I went in, modified my BPX params, did a set on VS, and sure enough, IPv6 was enabled. So that was the beginning, and it was a bit of a journey. We actually, by September, I had started working on all the program updates, all the application updates. It took a while for me to make all of the IP stack updates to my test stack there between April and September. You know, there were other things to do. So, but I made it work. September of 2008 was when I actually started all the application stuff. All the IP stacks were configured using IPv6 by February of 2012. So that seems like 3.5 years. It really was. Again, I could only update one IP stack at a time. At the time, I had 7 ZOS IP stacks to maintain, and I could only do one a month, and I had to have a couple of months in between in order to verify that everything was working. So yeah, it looks like it took a long time. It really didn't. But February 2012, all this stacks configured to use IPv6. Okay. Now my primary production ZOS system, that would be the last guy. I added IPv6 or IPconfig 6 into the TCP/IP profile at the end of 2009. By the end, I mean December 31st of 2009, I was adding IPconfig 6 into the TCP/IP profile. 5 weeks later, I enabled the IPv6 sockets in BPX params on that on the primary stack on that system. Configured all the interfaces, added the routing to the primary stack in November, which happens to be a year later, again, because of all the application development going on. And I added it to the secure stack on that primary system, February 2012. That was the end. Okay, so actually going from the primary stack here to the secure stack over here, there was another change in between, but it just took a couple months to make that change. And then all the IPv4 device link and home configuration specifications were changed to use interface in August and September of 2017 when we implemented ACI as our network software-defined networking. That was it. We had a lot of trouble. We're MVS. We had a lot of trouble with ACI. That was one of the changes that I made in order to try and make that work better. It didn't do it, but hey, this was one of the things that I needed to do. So that's when that got done. So basically, my configuration upgrade, it took about this long. Okay. Again, once a month. 7 stacks to do, 8 stacks now because I've created yet another IP stack. But that's how long the configuration upgrade took. I started with the software upgrade. I have a sockets API that allows me to encapsulate all of the assembler easy ASME calls that you need in order to do sockets work. So I created socket APIs to help support. Basically, I updated everything to say, hey, we're going to be using IPv6, so stick this in that, and it worked. That radically simplified the upgrade to like my telnet server here and my IP gateway. All right, you'll notice that I had to make some updates here. The actual change here to actually implement IPv6, it took maybe a couple of months. Down here, it took no more than a month because having learned everything up here, I could make all those changes down here. So the rest of this, again, as I said, this was a fairly massive upgrade to both of these products. They are very closely related and they work very similar to each other. One actually creates a subtask every time it needs to handle a new socket. The other loads up all the subtasks to begin with and handles them that way. So I can tell you about doing lots of fun work with sockets here. I did have to make some updates as far as my sockets API goes in order to support IPv6 activities along the way here, but Basically, when I started this implementation, I had about 13 to 17 of these APIs. By the time I was done, I had like 24. And again, I'm trying not to talk about all the application work, but yeah, but it works now. One of the other things that I had to do along the way was to upgrade my enterprise extender configuration. And this took, there's about a 10-month period here. I actually have a presentation that shows all the connections between all my ZOS systems that use enterprise extender. It looks like a very ethereal, space-oriented square dance. It's really very strange, but I was able to update enterprise extender to use both IPv4 and IPv6 as needed. One last thing I did over here, again, this was to remove all the device link and home specifications for IPv4 interfaces, rename them to using the interface command. We'll talk about that all the next time. The very last ones of these that I had to do was on my secure stacks, and I did that about 5 weeks ago. I updated both of my secure stacks 5 weeks ago in order to remove all of the device link and home specifications for the OSs and for hypersockets and for any application VIPAs and primary VIPAs, that sort of thing. All stuff we'll talk about the next time. So here's what we've covered so far. For ZOS, we've talked about planning. We talked about enabling the IPv6 sockets and configuring the name and address resolution. All of those things allow you now, if you do those today, you're able to start using IPv6 sockets and talk to other applications and hosts, at least on the same ZOS system, okay? You can't talk off onto another ZOS system or to anything else until we actually do the rest of the work, which is to configure the actual communication interfaces, okay? So whether we're talking about OSs or hypersockets or defining your primary or your application VIPAs, all of that stuff, and the IP side of Enterprise Extender, all of those things we'll talk about the next time. And we'll talk about some routing. We'll talk about what we have to do in order to configure the routing between IPv4 and IPv6. Okay?
Great. Well, thank you so much, Rob. This is you're ending just perfectly on time. Thank you so much. And guys, if you have questions, let me know. We're almost at the end of time, so you know, you may have time for one or two. Or please go ahead and send me questions. You know, through email too. And let me know if you guys want to set up an email list around all of this. And as you can see, then people, you know, people are, you know, it's going to take a while to get started. Now, one thing we do have a question about whether you use a network monitor, and so the one thing I am going to say, we are a nonprofit, and so we cannot mention anything, any product names. I mean, that's just something that we don't care to do. Anything we mention would be an open source. There are times we might have a sponsored presentation, or, you know, as I say, but for right now, I think that's kind of is our policy, is that we stay away from talking about specific products. Everything is, of course, I think you would say IBM mainframe is a specific product to IBM. But
right.
Hey, we need some competition.
And since we're talking about that, since we're talking about the IBM mainframe and ZOS, I can say NetView. We do watch things, but not much. I mean, we don't. And I'll tell you, you know, this is not a secret here, but, you know, I worked really hard to get my my implementation of IPv6 out there and done before anybody else at CAS had IPv6 going. I am well ahead of that curve. Nobody else is doing IPv6 yet. Okay, so at our place, really the only thing that uses IPv6 is the mainframe network. All of my VM systems, all my ZOS systems, all configured with IPv6. We use hypersockets back and forth constantly using IPv6, which to me is pretty impressive. But so we don't really have a network monitor. We don't need a network monitor per se for that.
And guys, you know, one thing, I will take that up to the board, the INTC board, and if that is of interest to people, if we might get a number of different people who have network monitoring tools, and they can all talk about it. And that's certainly, but as I say, that I think let's let the board decide how we're going to do that. One final comment is the TCP/IP display commands on the mainframe are much different than other platforms, for sure. Yeah, yeah.
Yes, they are.
Right. Yeah. Well, thank you guys so much, and thank you, Rob. And we will have part 2 in 2 weeks. And I hope to get Rob to talk about ZVM and maybe even application socket stuff on ZOS. Please send me notes. Please send me notes, an email, if you guys think that is of interest. And then I hope we can twist Rob's arm to do those as well. So, okay, thank you guys so much. Thank you, Rob, and hope to see you in 2 weeks.
That's great. Thanks.
Bye.
Bye now.